In our previous discussion, we learnt about encoding our payloads using MSF encode. This encoding, or obfuscating of payloads, enables us to bypass the antivirus protections present on your target machine. These encoded payloads can be executed on your target machine in order to open a backdoor entry for further penetration testing. Moving ahead, in this video we will further investigate MSF encode and MSF payload to generate more complex and encoded forms of payloads. We will be using one of the most popular encoding styles present in Metasploit, that is, Shikata Ga-Nai. As you can see, it's treated as an excellent polymorphic XOR encoder. Now let us start with a basic implementation and let's choose a different payload. We now need to set the L host. Alright, our L host is now set. Let us pipeline the MSF encode command. Now let's choose the number of iterations as 2, generate an exe and name it newencoded.exe. Alright, so 2 iterations have been performed and finally our file has been generated. It is of the size 54. What we can do here is that we can further increase the number of iterations to increase the complexity of our shellcode. We can further increase the iterations 10 times and rename our file as encoded10.exe. Let us see what will be the new file size. Alright, so now a file size of 270 kilobytes has been generated. But the file is further more complex compared to what we've generated so far. Let's further increase the complexity to 20 iterations for the same payload and rename our file as newencoded20.exe. The new file created is a size of 540 kilobytes. The complexity is increasing, the file size is also increasing. We have to make sure that we are choosing the correct combination of encoders along with the payload so that neither is the file size too large, nor do the number of iterations go beyond a comparable limit. Now let's go back to our backtrack root folder and see whether our files are created or not. Here we have the 20, and here we have the 10. So these are the files that have been generated finally. This was a quick demonstration of how we can keep increasing the complexity of payloads using the different available encoders. There is a huge list of encoders, and we can also combine the scripts of different encoders and generate a single encoder of our own, and further implement it to generate a more complex and undetectable payload.